One second. Okay, please be welcome to the Chemical Engineering Seminar. We have Dr. Mike Clifford. He's an associate professor in the Faculty of Engineering at the University of Nottingham, where his innovative teaching methods involve costume, drama, poetry, and storytelling. His research interests are in appropriate and sustainable technologies, particularly cookstoves for use in developing countries. He works with charitable organizations such as Tearfund, Enactus, Engineers Without Borders, and Creative Energy on technological solutions to tackle global challenges. The name of the talk is The Killer in the Kitchen. Could improved cookstoves prevent 4 million deaths a year? Thank you so much, Dr. Clifford, for being here.
Thank you so much, Pedro, and thanks for the invitation to come and talk to you. I would love to come and visit one day, but for now we'll have to do with just talking via screens. So yeah, I've got this title which hopefully has attracted some attention, and I always like a question in the title. And I should acknowledge my co-author here, Ben Robinson, who I'll talk about towards the end of this presentation. I have to give two apologies at the start. First is that, as I said, I'm recovering from COVID. So if I'm a bit short of breath and have to keep having some water, then please forgive me for that. And the other one is that the 5th of November is a strange day in my country, in that about 500 years ago, Guy Fawkes tried to blow up the Houses of Parliament. And every 5th of November, we celebrate I don't know why we celebrate, but we have bonfires and fireworks. So if you can hear fireworks going off in the background, you know, that's what's happening outside. I don't like it. I don't like the pollution and the noise. So I'm quite glad to be tucked up in my office here, talking to you instead, while my family are going out and enjoying the fireworks. They like the noise and the color and the cold. so that's a bit of the background. So today I'm going to talk to you about cook stoves and about history, how stoves have changed over the years. And I'm going to talk about why traditional stoves are bad, and then maybe why they aren't quite so bad. And then I'm going to talk about what engineers should do next, and then what we shouldn't do next, or the other way around. And then I'll do a little bit of sort of chemistry, a little bit of combustion science. We'll talk about how wood burns. And I'll introduce this Tled stove that I've been working on for a few years now. I'll share some stories from Nepal. We'll draw some conclusions, and I'll share some links, and we can have a question and answer at the end. So as a background, half the world cooks their dinner on open fires, often fueled with wood or charcoal or dung or crop residues. And according to the World Health Organization, this results in about 4 million premature deaths from illnesses around respiratory diseases, pneumonia, and those sort of illnesses. And a lot more people die of these sort of diseases than malaria, actually. You think of malaria as being a serious problem. Well, air pollution is a big killer. And engineers have developed a lot of solutions in terms of improved cook stoves, and we'll look at some of those. But most of these are used in cities for the sort of middle classes around the world. And there's a limited number of sort of larger stoves, and I'll talk a little bit about these larger so-called institutional cook stoves towards the end of the presentation. So a bit of history, starting in the top left there. I've been working on cook stoves for about 20 years, but the history goes back maybe to the 1970s. I don't know whether you're familiar with Schumacher, the sort of appropriate technology movement. And Schumacher wrote a very influential book in the 1970s called Small is Beautiful, Economics as if People Matter. And he talked about technology bringing people together rather than driving them apart. And he thought that technology should be understandable, and so you understand what's happening, and you can repair it. So, you know, when I first started driving, I suppose, I had a car, and you could lift up the bonnet, and you could look under the bonnet, and you could understand all the bits and pieces, and you could change the spark plugs and replace the fan belt. and you could do sort of basic maintenance on the car, and that would be almost an appropriate technology car, if you like. But I've just bought an electric car, and I haven't even lifted the bonnet because I don't know what's under there, you know, and I realise that there'll be lots of warning signs saying, do not touch, do not try and do this. If your car breaks down, just take it to the garage. So we've moved away from this sort of appropriate technology. But in terms of stoves, Schumacher was keen on sort of a DIY, do-it-yourself technology, build your own stoves, and then if your stove breaks, then you'll be able to repair it. So we had these very simple sort of mud rocket stoves in the top left of the diagram there. Towards the 1980s, then people started getting interested in improving the performance of cook stoves, making them more efficient, using less firewood. Deforestation was becoming a concern. And so that was the sort of driver. So we went from appropriate to improved. And then in the 1990s, the so-called Global Alliance for Clean Cook Stoves was formed in Washington, headed up by Hillary Clinton. I wonder what she's doing these days. And the Global Alliance were pushing this idea of clean cooking and clean stoves. And then more recently, the discourse has moved to talk about clean fuels, which is quite strange because the sort of fuels that they're talking about as clean are liquid petroleum gas and electricity as a clean fuel, which is quite strange because half the world is trying to get off these fossil fuels, but the other half of the world we're saying, you know, you should switch from wood to these so-called clean fuels. And I wonder whether it's a coincidence that the Global Alliance is supported by the Shell Foundation, who obviously have a vested interest in selling oil and gas. And then more recently, we've had this idea of modern or smart cooking. So the technology has really come on leaps and bounds. And the Global Alliance for Clean Cook Stoves has just rebranded as the Clean Cooking Alliance. And so I wonder what's next in this sort of story of history. This is the sort of stove that many people are familiar with around the world. I've seen a lot of these in sub-Saharan Africa and in other countries as well. This is called a three-stone fire. Very obviously why it's called three-stone fire, because you have three stones and you balance your cooking pot on them. And it's nice and flexible because if you have a bigger pot, you just move the stones apart, or you get bigger stones, and you feed in the timber, the wood from the sides to let it burn. So you don't have to chop the wood to feed it into this stove. But as we've seen, it's very polluting, very inefficient, and we have lots of problems with it. So what's so bad about cooking in this sort of way? Well, people have looked at the cost or the time that people spend collecting firewood for these sort of stoves, and particularly women and children who the burden of collecting firewood tends to sort of fall on in developing countries. And there's been talk that, you know, if the women weren't having to collect so much firewood, and the girls particularly, then they could engage in more sort of profitable activities like education, rather than having to help tend the fire all day and collect firewood. There's also been concerns around deforestation, which leads to soil erosion, and I'll talk a little bit about that later. That was particularly a driver back in the 1970s, 1980s. More recently, there's been concerns around the CO2 emissions, or black carbon or soot emissions. I think these stoves are responsible for about a third of the world's CO2 emissions and about a quarter of the black carbon. And with the COP26 summit going on in Glasgow at the moment, very much in the news about trying to limit CO2 emissions, and as well as limiting them from sort of big business and industrialized countries, then you know, the finger is pointed at developing countries as well in terms of the drivers towards climate change. And as I mentioned in the title of my presentation, then there's this concern that the indoor air pollution generated by burning wood and charcoal leads to health concerns and 4 million deaths a year that could be prevented possibly. Here's some publicity material put out by a charity called Practical Action. which sort of inspired the title for my talk today. It says, "Stop the killer in the kitchen. Household smoke kills more people every year than tuberculosis, AIDS, and malaria." And it repeats the details there. And if you look at the inset circle there, it says having an open fire in your kitchen is like burning 400 cigarettes an hour. And I'd like you to remember that figure there, 400 cigarettes an hour. So if you have an open fire, then it's like smoking 400 cigarettes an hour. Okay, so keep that in your mind as we go through the presentation. And Kofi Annan has called this problem a silent killer. I don't know whether a silent killer is any worse than a noisy killer, actually. I don't know. I think I'd prefer to go quietly if I'm going to be killed by a murderer or whatever, rather than a noisy killer. But maybe there's something especially sinister about a silent killer. So Kofi Annan says, for too long, cooking has been a silent killer, but we're seeing some momentum around this issue. And he thanks the Global Alliance for the sort of drawing attention to this problem. I talked a bit about deforestation being one of the reasons why people are interested in these sort of technologies. But when you actually look at it in more detail, the Global Forest Atlas says that actually burning wood for cooking is not really a driver of large-scale deforestation. It's more actually clearing land for agriculture. I'm familiar with sort of the Amazon, where illegal logging is being carried out to clear land, and it's not actually people cooking, which is the reason for that deforestation occurring. It's really clearing land for agriculture or for using the timber for other purposes. And they also note that charcoal production is an issue. It might not lead to large-scale deforestation, but it could lead to forest degradation. So it depends where you're looking. The top area there, the left-hand top picture, is from Ethiopia, from Addis Ababa, where I visited about 12 years ago now, and took that picture in the hills above the capital city, where you could see quite large-scale deforestation. Don't know whether that was due to people using the wood for cooking. I suspect it wasn't. I suspect it was for other purposes. The Forestry Commission in the UK say that burning wood is largely carbon neutral. That's as long as you plant more trees than you cut down. So actually, it's quite interesting to reframe this problem and say that actually if you replant trees, then using wood as a fuel might not be a bad thing. I was going to say something then. Yeah, I can't remember. Anyway, the picture here is from Ghana, and it's a big sort of flatbed truck loaded up with bags of charcoal. And charcoal is produced in the north of the country in Ghana. It's actually illegal to produce charcoal, but still loads of people do it. And they load up their vehicles, they overload them, and they drive them to the capital city, to Accra. And they overload them because they know they'll be stopped on the road by the police. But they also know that if you give the police some money or a bag of charcoal, then they will let you through to sell your charcoal in the city centre. So although it's illegal, it's the most popular fuel used in Ghana. We saw loads of charcoal being sold at every street corner, from big sacks to enough charcoal just to cook one meal there. Well, that's what I was going to say. So it's interesting when you look at countries like Ghana, in that the government, they have a ministry for energy, which is really concerned with oil and gas and electricity. And then they have the forestry ministry, and the sole thing that the forestry ministries are interested in is stopping people cutting down trees. And it's quite interesting that there's no connection between these two departments at all. You know, they don't really recognize firewood as being a source of energy, despite most of the population cooking using firewood as a fuel. Health is a big concern. I'm going to talk a little bit about this study that was carried out in Malawi a few years ago now, about 4 or 5 years ago, where they tried to look at changing people's cooking habits, brought in some new stoves, and then looked at the incidences of childhood pneumonia in under fives. And it was run by Kevin Mortimer, who's a lovely guy from Liverpool in the UK. And he was very keen to see whether changing stoves did anything for the health of children in that area. And some text here, it says here, results from this study, it's called the CAP study, led by the Liverpool School of Tropical Medicine, indicated that cooking with cleaner stoves had no effect on the incidences of pneumonia in children under the age of 5. And BBC News reported that Mortimer, the lead researcher, was expecting and hoping that a reduction in smoke would lead to a reduction in pneumonia, but it didn't. And we'll look at why why there wasn't a change in the health of the children in a little while. There's Kevin. He's a lovely man, and he says I would really have loved to have seen some benefits from this cook stove trial, but he didn't see any. It was interesting that the Clean Cooking Alliance had a very different press release on this story, and they said based on the stove evaluated in the Malawi trial, the lack of impact on child pneumonia was not surprising. Well, it was surprising to Kevin, who ran the study. But they said the Malawi study found a significant reduction in the reports of burns from participants. This is big news, and it's quite puzzling when you see these different sides of the same story. Okay, well, here's a graph. I'm aware that I'm talking to engineers, and I haven't shown you any data or graphs yet, so if you're getting nervous, here's your graph to look at. And this is a curve of looking at the relative risk of catching an acute lower respiratory infection in a child against PM. This is particulate matter under 25 microns. And we're looking at, as you increase the exposure, the relative risk of catching a respiratory infection increases. So let's put some data points on this curve. Here's the sort of safe levels according to the World Health Organization, the air quality guidelines. There's one for sort of short-term exposure and one for sort of 24 exposure there, and they're around about 10, 20 micrograms per cubic meter. But then if we put on some data from cook stoves, if you look at the top right there, if you cook on an open fire, then you're producing about 1,000 micrograms per cubic meter. Remember that statistic that I told you to think about. Cooking on an open fire is like smoking 400 cigarettes an hour. So clearly that's really bad. But then you think, well, okay, as an engineer, let's say we could halve the pollution coming from an open fire. So we could be down to sort of some of these improved stoves or putting a chimney on a stove. And you say, well, actually, that's still like smoking 200 cigarettes an hour. Well, that's not very good either, is it? And then if we switch even to a gas stove or an ethanol stove or an electric stove, we still get some particulates given off process, particularly if you stir fry your food or you burn it a little bit. And even if we sort of vastly reduce the amount of pollution coming off during cooking, we're still quite high up this risk curve. And we're still a long way away from the sort of safe air quality levels according to the World Health Organization. So perhaps that's why that the Malawi trial didn't see any improvements in health, because we were still, not really getting down beyond the flat portion of this curve before we'd see any reduction in pneumonia or other diseases. What other impacts are there on health? Ones that people don't look at so much. In the bottom right, you can see some girls in Zambia collecting firewood, and they're quite young children there, and they're carrying quite heavy loads on their heads, and that can lead to problems with their spine and problems with stunted growth. There's a lot of burns around cook stoves. The child in the bottom middle there is from Malawi. He's obviously playing near the cook stove. Fortunately, this is cooking is finished and the stove is quite cold. But many African children have burns related from playing around cook stoves. You can get problems with eyes. You can get cataracts. You could also get short-term sort of red eyes, and this can be actually a bit more serious than you might think, because in some cultures having red eyes is seen as being indicative of being a witch. So if you have red eyes, people will say you're indulging in witchcraft. And in some communities, that's a really serious problem, in that people still believe that witches are real, and you can be in big trouble if you're suspected of being a witch just because you've got red eyes, because you've been cooking on a smoky fire. A happier story, the couple in the middle top picture there are from Tanzania. And I worked on a project there on biogas stoves with creative energy. And we went back and asked people about the benefits of the stoves that we put in. And we asked this couple, particularly we asked the lady Maria there in the picture, what she thought was, how her life had changed with using a biogas stove rather than cooking on charcoal. And I don't know what we expected. We might have expected her to say that she was saving money on fuel or less smoke or whatever. But she said cooking on with this biogas stove had really improved her marriage. And the person doing the interview sort of stopped and said, "Excuse me, what do you mean it's improved your marriage?" And she said, "Well, my husband's a pastor in the church and he's an elder in the community. And it's considered really bad if elders' eyes are watering. So he never used to like coming into my smoky kitchen. I mean, because if his eyes were watering, people think things were bad were happening in the community. Actually, I think he just didn't like coming into the smoky kitchen. But now I cook on biogas, my husband comes into the kitchen more, and we talk about the family, and we talk about the children, we talk about the farm and about the livestock. And our marriage has improved because of this stove." And that was quite an unexpected and really sort of heartwarming finding from changing cook stoves. So what problems do clean cook stoves solve? Well, there's some evidence that collecting less wood is helpful, but actually there's very limited information that says that children actually spend the saved time doing anything productive like education. Talked a little about deforestation. Actually, forest degradation is perhaps caused by cooking with wood, but there's limited evidence to say that cooking on wood is a real cause of deforestation. Talked a little bit about the indoor air pollution problem around health, and climate change is obviously very much in the news. I think the biggest problem that clean cook stoves solve is they make cooking a little bit easier for people. But unfortunately, this isn't enough to sort of open the wallets of the donors or the funding agencies. So we have to sort of talk about climate change or these big kind of issues to get projects funded. But what's not so bad about cooking on traditional stoves? Thinking about this picture of these children collecting firewood, actually they're doing it together. They're doing it as a kind of community event. Sometimes women actually quite like going out and collecting wood together with other women. Wood, if you plant more trees than you cut down, is a sustainable fuel. It can be free, and if there's plenty of wood in your locality, then that's quite a nice fuel to be using. It's culturally appropriate. People like cooking on wood. They like the taste of food that's cooked on a wood fire. In the UK, when we have our 2 weeks of good weather in the summer, everyone likes getting out in their gardens and cooking on barbecues and open fires. Even though we've got much better cookers in our kitchens, there's something about cooking around an open fire that people actually like. And so we should remember that as well when we're designing stoves. It's also quite an adaptable way of cooking as well. So what shouldn't we do next? This is a picture of a yak, okay? And as engineers, we're very good at looking at these problems and saying, oh, what we need is a new cook stove. Yet another cook stove. That's my yak. That's what it stands for, yet another cook stove. And we sort of poked fun at these stoves a little bit in that stoves seem to be getting more and more advanced. And we kind of imagined that one day maybe And stoves exist that kind of have charging points for mobile phones and all sorts of interesting gadgets with them. And we wondered where this was heading. So we employed a cartoonist to kind of dream a little bit about where the technology of cook stoves might be heading. And he came up with this cartoon, and there's two ladies here, and the one's saying, "Nabetha, come and look at my new cook stove my husband's bought me." And she says, "Really, I have to see it." And there's a traditional stove in the bottom left there, a Malawian stove there. And this lady's very proud of her stove. Look, she says, "What do you think? It does much. It cleans the house, it answers the phone, it goes to the market, it makes juice, it reads to the children." And her friend says, "Oh, how does it cook?" And the lady is just cooking on her own old stove there, her 3-stone fire. And she said, "Well, I wouldn't use it to cook on." I've seen a lot of stoves around the world, and I've seen stoves that people have got in their houses, and they've said, "Well, this is such a beautiful stove, I wouldn't use it to cook on." I've heard of stories where people have used them as stools. They've turned them upside down because they prefer to sit on them and cook on the traditional fire. And I've even heard a story where someone's used it as a vase and put flowers in it and said, "Look, it's such a beautiful thing, I couldn't possibly cook with it." So sometimes we just reach as engineers for technology and technological solutions rather than sort of understanding the culture around cooking. Here's a slide with various cook stoves. This isn't from my lab, but actually I've got about the same amount of stoves in my lab. All these kind of ideas and inventions, all of them quite small actually, or most of them very small. Most of them fairly too small for the sort of family use. People have got extended families often, and these stoves are actually pretty small when it comes to cooking a family meal on them. So what should we do next? I think we should take a holistic approach. Look at forest management, look at fuel production, look at the whole story of transporting fuel into cities. Look at the manufacture of stoves, look at technologies. Actually, if you want to save energy when you're cooking, putting a lid on your pan saves a lot of energy rather than changing your cook stove. We need to think about household dynamics. We need to think about culture. We need to think about food. Actually, when you read a lot of technical papers on cook stove design, they don't actually talk about what food is cooked on the stoves that are being designed. We need to think about waste and health in this holistic approach. I'd like to talk about sort of healthy cooking rather than clean cooking. So that kind of brings me on to the idea about institutional stoves. And maybe there's a gap in the market. Having said, you shouldn't design lots of new stoves, actually, maybe there's a space for an institutional stove. Institutions, I'm thinking of schools, I'm thinking of prisons, I'm thinking of monasteries, I'm thinking, all sorts of organizations where cooking is done on a larger scale. Larger pots need larger stoves. They're typically cooked on for longer, so that's going to cause more pollution, and it's going to cause more health problems for the cooks that are using these stoves. And actually, if you look at the Clean Cook Stove website, there's only a few commercial large-scale stoves that are actually available at the moment. So that's a bit of an idea. I'm going to talk a little bit now about wood combustion, very briefly, and then tell you a little bit about a project looking at a design of a new institutional scale stove. So if you burn wood, there's really sort of 3 or 4 stages that wood burns with. The first one is that if the wood contains any moisture, as the wood gets hot, the moisture is driven off and you get quite a lot of smoke. So it's better to cook with dry wood. And then you get volatile organic compounds given off from the wood. You get wood gas, and that burns in primary combustion. If there's enough oxygen, then you get some secondary combustion as well, get a cleaner burn. And then finally, once all the wood gas has been given off, the wood burns and chars in this sort of final stage, char combustion, which is also, again, when a lot of pollution is given off. And you can see that you can do your own experiment at home with a match. If you light a match, you'll see the combustion front moving down the match, and actually, rather than leaving ash behind, you'll leave char behind, because these pyrolysis gas, the wood gas that's given off, forms a sort of blanket around the char and protects it from burning, because it removes oxygen from the surface of the wood there. So we have the fire triangle in the bottom right there. To create fire, you need three things. You need heat, oxygen, and fuel. And that pyrolysis front moves down the match and actually restricts the flow of oxygen to the char, and so it doesn't burn to ash. And that leads us to a sort of fairly new design of stove called the Tled stove, which is a top-lit updraft stove. And the idea here is that rather than burning wood to ash, you only burn it as far as charcoal by taking the pyrolysis front and taking the wood gas away from the surface of the burning wood, and through some fairly clever sort of design there. You can either use a built-in fan, or you can use natural convection to achieve this kind of combustion. And Tled stoves have been around for a while on a kind of household level, but we thought we'd try and make an institutional scale Tled stove. Which brings me to introduce you to Ben. Ben is a fairly amazing student. He did his undergraduate at University of Nottingham, and then I persuaded him to do a PhD, and now he's doing a postdoc with me as well. And he'd worked in Nepal with an organisation called Live to Love that were giving away fairly small rocket stoves to the community. But he saw that there was a need for a larger stove, and he did a project with me when he was an undergrad, and then I persuaded him to do a PhD and take the work a bit further. So he came up with this Tled stove. There's a schematic of it in the bottom right, and some temperature tests from the lab on the top right there, and a lovely picture of Nepal in the middle of the slide. So what we wanted to do was to make 10 institutional scale stoves, and we wanted to make them in Nepal, in Kathmandu, the capital. We were going to distribute these stoves to institutions that were likely to use them, but also be able to afford to purchase the stoves. We were aiming to make these stoves for about $100. So rather than give them away for free, we said, well, you can borrow these stoves, and at the end, we'll either take them away or you can buy the stoves from us. In reality, we just let people keep the stoves, but actually it put off some people that were just looking for a free stove. So it was quite a useful tool to restrict our kind of audience. We looked at evaluating the stove performance in terms of engineering parameters like efficiency and emissions, but also we did some qualitative work asking people about their experience of using the stoves. We did some semi-structured interviews with the users. And we've been improving these stoves based on the field tests and also the feedback. So here's one of the stoves undergoing testing in the Centre for Rural Technology in Nepal. And we used the kind of standard stove test, a pot boil test. And you get a tier rating. Tier 4 is the best. Tier 1 is the lowest there. And actually we found that the testing wasn't very good for our stove, because we weren't burning the wood to ash. We were purposely leaving charcoal at the end there. So our thermal efficiency is lower than you might expect from these sort of stoves. But that's because we're leaving charcoal behind. And we're leaving charcoal behind for two reasons. One is that burning it in this stove would lead to increased emissions, and we were trying to get the kind of emissions down. And also you can use this charcoal subsequently as a biochar, as a soil improver, or to help with water filtration, or you can actually use it in a charcoal burning stove at the end, so it's not thrown away. It's a useful material. We managed to boil 5 litres of water in 22 minutes, and we could make these stoves for around about $100 US dollars. There's the manufacturer in Kathmandu. And here's some of the locations that we were trying out these stoves. We tried them in a plant nursery, in a school, with a dairy farmer, cooking for cows is quite an interesting kind of idea. In the sort of high areas of Nepal, they cook up the cattle feed. So we didn't know that before we started, but that was quite an interesting application. We also used some in some monasteries and some schools, and one was left at the cookstove testing centre. So here's some feedback from the school. Really interesting from the teachers. They said that the kids have been amazed by this cookstove. They've been thinking about ways to help the cook remove the pot from the stove more easily. We have a sort of pot skirt around the pot, so it's actually quite difficult to lift the pot. It's actually better to sort of ladle out the food from the pot while it's still on the stove. They liked the fact that you didn't have to keep monitoring the fire. You could do other tasks at the same time because the cooking was quite controlled. They were using liquid petroleum gas quite a lot, but for this stove they found they were using less gas, and it was particularly good for using big pots. Now, some people would say this is a step backwards, going from biomass fuel, going from LPG, from a so-called clean fuel, to a biomass fuel. But actually we're in an area where wood is quite plentiful, and we think actually burning wood is quite culturally appropriate and more sustainable than using LPG, which is brought in from China. It's very expensive and has all sorts of problems around the extraction of the fuel. More feedback from the school. They said actually, but we like to sit around the fire. And the children like to sit around the fire, but we know it's not very safe. But actually, there's something about sitting around the fire that we miss. But we quite like this stove in a way of teaching children about sustainable living. And they say, we definitely buy some of these if they were guaranteed for 1 or 2 years. From the farmer, a lot of text here. I'm not going to read all of these quotes, but the farmer was very delighted that he was saving money with these things. He was probably saving about $200 a year. And as a result of using this stove, he bought another cow, actually. And he'd got loads of suggestions about trying to change the design. Because of the design of the stove, it's a batch stove. You have to fill it with firewood, burn it, and then empty it, and then fill it again. And he'd like a mechanism of being able to add firewood as the stove burns, and that's quite difficult with a Tled stove. So some concluding thoughts before I move on to kind of some questions. I started off with this question whether stoves could save 4 million lives a year, or could they prevent 4 million deaths? And I think it's not very clear whether they can, because actually reducing the pollution to a safe level is very, very difficult with any sort of stove, let alone a biomass burning stove. In a small way, we've been using these institutional Tled stoves in Nepal, and we found that the test standards don't necessarily correlate with the performance of the stove or the priorities of stove users as well. So we've kind of emphasized this need to talk to the people that are using the stove, rather than just saying, oh, this is more efficient or better burning for you, so you must use this stove. The stoves have been in sustained use for over 3 years now, and we haven't had any reports of any of them failing. We've been in touch with the people that are using them, and particularly the farmer is using the stove every day, so it's lasting really well. So that kind of raises the question, maybe there's a market opportunity here for an institutional-sized Tled cook stove, so we're quite interested in pursuing that. But like every research seminar, I'm going to say that more work still needs to be done on the design of the stove, but actually also on that qualitative side and understanding people's cooking needs and really what they need from a cook stove. And I'll just end with some links. I've sent this presentation over to Pedro so he can circulate it. If I was giving this presentation live, I would show you a couple of video clips from an event called the Great African Bake Off that we had at Nottingham, where we used ladies from the Refugee Forum, Nottingham Refugee Forum, who come from sub-Saharan Africa, and we brought them onto the university campus, and we had all of my stoves from my lab, and we let them use them and cook with them and give us some feedback on how they found using these stoves. So particularly in these kind of COVID times where travel is difficult, actually in Nottingham we have the world at my doorstep. So we have many cultures in the city, and it was really good to use those perspectives to feed into our research. There's a nice video of the work in Nepal at the YouTube site there. And if you want to hear more from me, there's a 15-minute podcast and a short blog with some more stories. And if you do want anything more information, do drop me an email at the address on the slide there. But that's the end of my presentation, and I'm happy to take some questions. So I'll try and stop sharing the screen, and then you can tell me what you think.
Thank you so much, Dr. Mike Clifford. I can maybe be the first to start asking questions about your work. There's, I know that you try to use materials from the geographical cities or countries that needs these kind of stoves. What is the material that is made the stove in this prototype?
So the one in Nepal was sheet steel. Initially, when we designed the stove, we thought we'd use an oil drum and sort of try and reuse an oil drum. But actually, we found when you go to some communities, materials that you might think are scrap or just, of no value are very valuable to communities. So we found that actually oil drums were quite prized. So we thought actually it's better making it from sheet steel and making it higher quality and made locally there. So steel seems to be quite available in Kathmandu at least. So that was the material that we made most of the stove out of, and it seems to last quite a long time as well.
Well, thinking about the heat transfer, did you evaluate different steels, not only to have the shape, also the function as a stove?
No, we just used what was available. So I don't know the spec of the steel. I think sort of longevity was perhaps more important than anything else, and we needed a steel that was weldable. So we had to use something that was available.
And the other thing I thought about is if steel is available in Nepal but not in Africa, that's the thing. No? You want to reproduce the scale, maybe the same stove, but in Africa there's no material like that. Can you have a different approach to that?
Yeah, you could use Adobe. So you could make this out of bricks with mud and straw. So you could make a stove out of that. You'd have to sort of experiment a bit with how long these stoves last, because sometimes mud stoves will last a few months and then start to crack. So that can be a problem.
I've read, not recently, but it's an old book, Abundance from Diamandis and Kotler. They were talking about, a radical improvement in Africa, maybe to have more, to have less people dying from respiratory infections, and that is to have an electric stove. But then we think about the electricity, and in Nepal maybe it's not available as we have in maybe Mexico and the UK. On different areas of the country, they don't have electricity. But is seeing the graph that you showed us, the particles that cause the infection, the respiratory infections, are not controlled with the electric stove, right?
It depends what you're cooking. So particularly, I've heard if you can smell the food that you're cooking, you're probably killing yourself because of the particles that are coming, which is not good, because you like to smell food when you're cooking. I think the other thing with electric cooking, particularly when I've worked in places like Nigeria and Ghana, that even if you're in a city with electricity, you don't know whether the electricity is going to be on all night. there's so many power cuts and blackouts and brownouts, and sometimes the cooking dishes take a lot of energy, a lot of electricity, and you don't want to have a half-cooked meal and then the lights go out and it's kind of, oh, right, how do we finish cooking our dinner?
And I also remember a colleague from Argentina, Victor Brownstein, talking about trying to change the way we use cars, maybe try to change or buy an electric car. But he also noticed that if you live in China and you are using an electric car, the electric car really is for burning hydrocarbon fuel to produce electricity, and then the car is moving not by electricity, it's by burning some minerals, maybe.
Yeah, and I guess it then depends. The efficiency of burning your oil in the power station or burning it in the engine, isn't it? So it might be a little bit better, but it's better if the electricity is coming from a renewable source. So that's very important. Yeah, and then you have all the issues around lithium and mining all these materials, and I like history, and I've got an old book called Modern Power Generation that was produced in 1909. And it's a beautiful book. It's got all these lift out pages, so you can look at a boiler and you can lift the cover and all the bits. Really sort of old book, and it compares cars. It says 3 designs of cars are available: steam cars, and they say the problem is the heaviness of the boiler, and then they say electric cars, the problem is the weight of the batteries, and they say petrol cars, the problem is the pollution and the inherent objections to the four-stroke cycle. And you think, actually, 110 years later, we're having almost the same conversation. And if you think steam cars, well, replace those with hydrogen vehicles, if you like, because basically a hydrogen car is a steam engine. You're burning hydrogen, you're producing water vapor. But 100 years on, still heavy batteries are a problem, and range of vehicles, and still the sort of pollution coming out of the cars are a problem.
And also the hydrogen is the risk of have this gas now. It's not easy to handle. So
driving with a bomb under your seat is
So Omar Rogelio is asking something in the chat. Thank you, Dr. Mike, for your talk. In Mexico, maybe people, perhaps millions, cook with traditional cookstoves. Is there interest in your part in coming and advancing your research in our country?
Oh, I'd love to. I'd love to. I haven't worked much in Central America at all. I've had one student a long time ago. I can't remember where he's working, but I'd be interested to know what's happening in Mexico with stoves. I know there's quite a lot of interest. I think Eprovecchio, a kind of organization that are working in that in your country, but I don't know. I'm interested to know what the situation is in terms of deforestation as well, whether that's a problem, and whether it's blamed on cooking or whether it's clearing land for agriculture, or what the situation is.
It's a complex situation in Mexico. It's not as easy to explain. It's hard. But there's some cities and towns that are not very close to the energy resources and things that are using the same thing from maybe 300 years from now. So it could be nice to have a project around that. Doctora,
I've got a called a La Plancha stove, which you can cook sort of tortilla on and whatever. There's one of those in my lab, which is a really nice stove. but it's like I think it's about $300 US, and you think a lot of these stoves, if you have $300 US, you'd pay someone to do your cooking for you. You wouldn't buy one of these stoves,
Maybe.
And some of the Malawi trial, the stoves that were used there were about $150 US, and you think this is like someone's salary for a year, and if you had this sort of money, Yeah, and that's part of the issue, actually. I mean, I think a lot of problems can be solved with money. But if you go into a community and say, if you had $100, what would you do? No one would say, "Oh, we'd spend it on a cook stove." They would buy a car or TV, or they would, fix the house, or they would send the kids to school, and they would buy medicine for their relatives. There's so many needs in these communities, and cook
Yes.
stoves they're not on the first page of people's wish lists.
Okay. Another question from Dr. Elena Hernandez. Thanks for an interesting talk. I wonder if the stoves you talk about are supposed to be portable.
The big ones that we've looked at are not particularly portable. Having said that, they're more portable than the sort of brick fixed stoves. So you could move them, but you wouldn't want to move them every day. So you can move them.
So and the other thing I've been thinking about is the material science challenge. That I know you work also with composites. I saw a big number of prototypes in your office.
Yeah.
They were made of different materials. There's a chance to use composite in some way in this kind of application?
Oh, I don't know. The trouble with composites is that they tend to burn fairly easily. And it's more the resin that kind of holds the composites together. That if you want to get over about 200 degrees C, then you need some quite expensive materials there. So I'm not very optimistic. I think that the sort of composite that works pretty well is mud and straw. That's a nice composite material. Yeah. And then actually, if you use that as a stove, the straw burns away, so you have some nice air holes in the material, so you have some thermal insulation as well. So yeah, old composites, but yeah, not carbon fiber.
And the other thing I was thinking about is also with the carbide issue is that we need ventilation. Maybe we produce gas of the combustion, and maybe the solution for this issue could be designing a way to remove this air.
Yeah, and that's tricky. So if you're in somewhere like Malawi, ventilation, great, it's very hot. If you're in the hills of Himalayas, if you're in Nepal, I saw a design with they're called smoke hoods, or rather than having a chimney on the stove, you have an open area and it takes the gas up. And I remember seeing a sketch of this, and one of the people there said, "Oh, it'd be really good actually to sit in this kind of chimney because you'd keep nice and warm because of the hot gas would go out. And if it's really cold, the last thing you want is a big hole in your roof. It's So it depends on areas, and we also see quite a lot of seasonality around cooking. So Malawi, for example, you have a wet season and a dry season, and the dry season's fine because you can cook outside. Ventilation's really great. The wet season, where the fuel gets wet, so you have more smoke, but actually you can't really cook outside, so you're cooking inside. Lots of smoke problems. So, it depends when you go and monitor the smoke. If you go in the dry season, you'd say, "Oh, what's the problem? Everyone's cooking outside, it's fine." You go in the wet season, big problem. Yeah.
And do you have made some simulations about the heat transfer in the prototypes?
Yeah, we've done some sort of computational fluid dynamics modeling. I had a student years ago who had a title of his thesis was "Breeding a Better Stove." So he had a sort of artificial intelligence thing linked with the CFD. So you ran the simulation and you got the result, and then the genetic algorithm would kind of evolve the stove a little bit. And that worked up to a point. I think a lot of the combustion models for wood are not very well developed, because all the money around wood combustion for co-fired sort of big power stations, well, you know that the best thing to do is chop the wood into small pieces, co-fire it with coal or whatever, and you can model that very easily. But it's really quite difficult modeling a stick of wood. So the sort of sized chunk of wood that someone burns, half the world cook this way. it's really hard to model that because you've got multi-phase, you've got the gases coming off, you've got moisture coming off, you've got chemical reactions going on. It becomes to get quite a challenging computational problem.
And the wood have a different composition. It's a different type of wood, really.
Yeah. So again, a lot of these stove tests, they say, oh, you need kiln-dried timber, and you need to cut your sticks of wood to 25mm square sections, carefully planed and dried in the oven before you test them, and you do your efficiency test. But then you go into the field, and well, people are just, taking twigs from trees or whatever, and the efficiency that you might get on a stove in a house in Malawi or wherever is very different to the test that you got in the lab, because the fuel is very different and the conditions are very different as well.
Okay, the last question is from Dr. Victor Alcaraz.
Yeah.
Wood is not only used for cooking, but also for heating rooms in houses or for heating bath shower water in cold countries. Are these contributions taken into account when calculating risk?
Yeah, so that was very interesting certainly with the Malawi project. They found that it's called stove stacking or fuel stacking. So, if you go into my kitchen, I've got a kettle that I boil my water for my cup of tea. I've got a microwave, I've got a fan oven, I've got a sandwich toaster in the back of the cupboard somewhere. There's probably a dozen ways.
Maybe the air fryer also, no?
Yeah, no, I have one of those. But I have so many different ways of cooking, and yet when we design for developing communities, sometimes we say, oh, this is the one stove that you should use for everything. And if they're heating water for a bath, well, you need quite a big, big pot to heat the water. You can't do it on this tiny little improved cook stove. So you might be doing a lot of your cooking on the improved stove, but then you light a big fire to heat your bath water, or you're burning the crops around the house to keep the sort of animals away from your property, or burning stubble or whatever. So there's all these different sources of air pollution, and there's all these different sources of risks around burns. We did some interesting work again looking at children and the attitude towards burns, and in a lot of countries we've seen that in some cultures there's no word for accident. There's this kind of fatalistic thing of, if something's going to happen to you, it will happen to you. So if there's no word for accident, then accident prevention is just, you can't prevent accidents, they just happen. And often children play kitchens in the way that perhaps my parents' generation played kitchens, in that you have a little bit of fire and you have a little tin can and you put some porridge in there and you get some grass and you have a real fire. Whereas, the way my children play kitchens is plastic food, and they don't have anything hot at all. So there's a very different attitude around risks, and actually around some of the improved stoves. One of the unintended consequences has been that parents have said, "Oh, this stove is so much safer than my 5-year-old can cook the dinner now." You think, well, that wasn't what the intention was.
Yeah.
So we're dealing with cultures where risk is very different, where attitude around injuries and attitude around burns actually as well. The best way to teach people about fire is, if you get a little burn, then you won't get a big burn next time. You'll learn your lesson. And that's not great, particularly if the first time you get a burn, you get a really serious burn, because then you have poor access to health care, and you can have, children that are losing limbs, or gangrene sets in and getting really serious problems around burn injuries. So that's a big problem around stoves as well.
So thank you, Dr. Mike Clifford, for your talk. I hope we can continue the discussion about, maybe you can use some of your knowledge in Mexico in different situations that we have here. And it should be a good project. So thank you so much for being
that'd
here.
be lovely. And yeah, I'd be very keen to collaborate with anyone. Do drop me an email if you want to carry on the conversation. And thanks so much for the invitation. You can tell that I could talk about cook stoves all evening. So it's been an absolute pleasure.
Okay, thank you so much. So the slides that Dr. Michael Clifford shared to us is now on our website, so you can check them out in the website of the PhD program. Thank you so much, Dr. Clifford.
Great, thank you. Have a good afternoon.
Thanks.
Bye.
So I'm going to stop the recording.